I think we get started. Let me share my screen. Hi, everyone. My name is Eric Mealy. A little bit about myself. I've been involved in FIRST since I was in high school. I've been volunteering ever since for about 15 years. I'm a technology teacher. Been teaching for 8 years, and I have a FIRST LEGO League team. This will be my 4th year having a team. There we go. Okay, the goals for today in this session, and an overview of what you're going to need to succeed here with FIRST LEGO League. I'm going to give you an overview of the EV3 and the Spike Prime, what you need to build a basic robot, go over some of the hardware, give you all an overview of the LEGO software, and most importantly, be able to get your robot moving. I think this has been covered, but just to go over it again, highly recommend a laptop or a computer. You can certainly use a Chromebook tablet. There are apps available for LEGO offers apps for the EV3 and the Spike Prime, but they're not as inclusive. There are some features that are missing. So again, highly recommend a laptop or a desktop. Spike Prime Education is the new robot to be released. It is still being sold. Rumor has it, though, just until they're out of inventory, they're no longer going to be selling it. The education version is recommended. There are some different things included within each of the different kits. There was a home version and an educational version. The LEGO software can be downloaded from LEGO's website, which I'll give you that link later on. Of course, you'll need your FIRST LEGO League Challenge kit and a table for the challenge to go on. The biggest change to the E3 and the Spike Prime is the software. They are using a programming language called Scratch, and the EV3 and the Spike Prime both use the same programming language. Scratch is a visual block-based programming language originally developed by students at MIT to help introduce students to coding. So it is fairly straightforward, but of course there are always some challenges with any coding language. The software you'll need will be specific to the robot you have. The software is laid out essentially the same, which we'll go over. But if you have an EV3, you'll have to download EV3 software. If you have a Spike Prime, you'll have to download the Spike Prime software. You can send and communicate to your robot through Bluetooth. Most laptops now have Bluetooth. If you're using a desktop at your school, they may not. So of course you can hardwire through USB. And we're going to start off by using a basic robot. I believe that question was asked earlier on in the other presentation. Highly recommend as a new coach start out with the basic robots that the software starts you with. That'll give you the basic robot to be able to get you to move around, and you can build and advance from it. Before we get into this, just a quick question to everyone. I have another device looking at 2 robots. Can you all see that? That's what I was asking Rick for. If you go through gallery, you might be able to see that also. Everyone see that?
I only see the components screen.
Okay. Just give me 1 second. I'll see if I can get that sorted out.
If you go to the gallery view, his second screen is near the bottom.
Got it.
Okay, so you can see it. Okay. An overview of components that you see on my screen that I'm sharing and my second device. Here we've had the EV3, and here we have our Spike Prime. Is anyone, just out of curiosity, is anyone using an EV3 here? Are all of you new coaches? EV3, one of each. Okay. And I'm assuming this is all your first time coaching a team using this using this hardware. Okay. Roy, you've been using it for a long time.
Yeah, I actually started out at mentoring first robotics in the high school, and I've made my way down to First Lego League now. So this is my fifth year at First Lego League.
Okay. Obviously, you can stay where you want. Would you like to go over to the, if you understand the basics of it, do you want to head over to the advanced session?
No, actually, since we're going to scratch, that's kind of like a curveball for me. So I want to make sure I got that going.
All right, no problem. So overview of the software, I'm sorry, of the hardware. Our robots are made up of the brain, the main hub. We have our EV3. The difference is the size. They're much more compact. What you see on my secondary screen here is both robots. These are both of the basic robots that this software shows us or gives us to build, and do the exact same thing. But this new Spike Prime is much more compact. There are some different features compared to the EV3. The EV3 has a screen and head. Spike Prime does not have a screen. The matrix behind it, which we'll go over in a little bit, and our on-off button. There are also, the Spike Prime has 2 less inputs for sensors or motors. We have large motors, small motors, and a variety of sensors. Touch sensor, gyro sensor, color sensor. That's not what I wanted. That slide go. There it is. Just a quick overview of the sensors. The ultrasonic sensor is used for measuring distance. Color sensor will allow you to navigate on lines of the field. Those black lines that were on the field, they have a contrast between the white edges and the black stripe. The color sensor can be used to help navigate and follow that. The touch sensor is what was called with the EV3. It's now called a force sensor with the Spike Prime. It's good for a wall or an object. And a gyroscopic sensor measures the orientation of your robot. The EV3 has that sensor separate. The Spike Prime has that sensor built into the Spike, to the hub itself. So it's not an additional sensor for the new system. Okay, I'm going to switch over to the software itself. Does anyone have any questions so far about the robots or anything like that just yet?
Spike Prime is different from an EV3.
I'm sorry, say again?
Spike Prime is different from an EV3, so they're two different little robots.
Yes. The EV3 was Lego's previous robot version. The Spike Prime is their newest one. They've stopped making the EV3. Rumor has it they're just selling off inventory that they have. They're not making any more. And again, the Spike Prime is the new one. They are different. They do the reason. The one on the left, my left here, is the EV3, much larger. But again, it does have a screen on it, does have a directional pad to help navigate your programs. The Spike Prime is a little more compact, but that's just the newest that Lego makes.
I'm sorry, Eric. When the teams are competing, are they required to only use one? Like, can they switch out between the Spike and the EV3 or no?
Truthfully, I've never seen a team do that. I don't know why. Truthfully, I don't know why you would want to, because you're building a robot to perform specific tasks. You'd have to have and build a secondary robot. I don't know if that is an issue. That would be head referee Troy question. Certainly write that down if you can get hold of him. That's a good question, though.
Hey, Eric, sorry about that.
Sure.
Yes, can you hear me?
Did you hear that question?
No, I did not. Sorry.
Okay. Sorry, I don't know who asked it, but the question was, can a team switch between a Spike Prime and an EV3? I guess if a team has two.
So between matches, you can have any controller you like. You can't switch during a match, but between runs, you can run one program with EV3, one with Spike Prime. That's not an issue. It's just in the competition area, you can only have one. So for each time you come up to a match, you can only come up with one.
Okay, so a match is, so they have 3 2.5 minute time periods where they can run their missions. And for those 3 2.5 time periods, they have to use one robot. Is that what you're saying? Or like
Exactly.
Okay. I just ask because with our district, like they're not allowed to touch a lot of the same things.
Okay. Yeah, so that's perfectly valid. Each match can be run with technically a different robot.
Each match, you said.
Yes.
Okay.
Which one is better?
I don't know. This is my first time working with the Spike Prime. You know, it's the newest one. It's going to be better in certain ways. They've come out with a new system for a reason. I'm not going to say one's better than the other. The Spike Prime certainly has advantages over the EV3, and the EV3 certainly has advantages over the Spike Prime.
Is there anyone else that has used both that would be willing to answer? Not just Eric, I guess. No, it's okay.
I know with my team in my district, I have EV3s. I'll be using EV3s until either they die or they don't allow us to use them. And that's only because I have them and funding through the school districts are tough. I'd rather put the 300 or 350 for the Spike Prime elsewhere within my programs because I have them. But if you don't have one at all, truthfully, I would go with the Spike Prime because they're still making the parts, making the components, they're still making the sensors. EV3 will soon be obsolete, and whatever supplies are in existence, which of course is a lot out there, but if you need parts, you need motors, you need sensors, you're gonna have to hunt them down. You can't just go direct to Lego for them. So moving on, here is the Spike Prime software. I'll be toggling back and forth between the two just to give you all an overview of everything that we have and show the similarities and show the minor differences. So my screen right now is the opening screen to Spike Prime. And I'm going to switch over to, this is the opening screen to EV3. The only major difference is this one has resources for the EV3, building instructions, programming resources, and this one has building instructions and resources for the Spike Prime. Left side, we have our home, start, learning units, teaching units, building instructions, all of your projects, help and settings. For those who haven't opened the software yet or for the first time, building instructions are built into the software, but if you click on build to look for those building instructions, there's nothing here. You would go to units, and there are unit plans for a variety of different topics. What I would start with is there's a specific one for First Lego League Competition Ready. Simply click download and it'll begin to download, and those build instructions will show up. When I first started playing with this software, I download all of these, and which you'll see in a minute. So with this competition ready unit, there are, waiting for it to load, but I believe there are six different build instructions just for that one unit. When I downloaded all of these units at once, there's so many, there's many different build instructions per each one of these little units.
Eric, I hate to interrupt you, but a lot of us only just see the block code. That's it. Is that what we're supposed to be seeing?
Yeah, it's not your program. It's like the slide.
Okay, sorry about that. Let's see. Oh, stop sharing. How about that? Okay. Sharing is paused. Why? Okay, sorry about that. The EV3 code is Scratch as well, yes. It can also be done in Python. That's much more advanced. Shift. Okay. Okay. Thanks for the heads up on that. So right now you can see the EV3 start screen. Just Just want to make sure.
Yes.
Okay. And right now you can see a building instruction screen. Oh, Spike Prime. Okay, I got my other device set up here. And then now you can see my PowerPoint. Okay, sorry about that, folks. All right. So I'll repeat that quickly. This screen that you see here is when you first open the Spike Prime set. Software. And this is the EV3 software. When you go down to units that I said before, it will show you many different lesson plans that are available that are built into the software. The one that I mentioned before, competition ready, download that. And that will give you building instructions. Until you download that unit, these building instructions will not be here. Like I was saying before, when I first started using the software, I downloaded every single one of these unit plans, and there were dozens of different building plans, and I didn't know which ones to follow. In the event that you accidentally did that, if you go to Settings, General, you can delete all unit plans and it'll remove all of them. Then you'll have to just download. I recommend downloading for now, just to start, just the one. The one for competition ready first LEGO League. The robot I started with was Driving Base 2. If you can see my second screen, which I'm not sure if you can. Let me take a look. I started with that bot, and when I first started my team 4 years ago, I started with the basic bot that was in the EV3 software, and that's still to this day, the 4th year we're doing this. That's the basic platform that my team uses. It's really the accessories, the additions that you add to it, is where your team is going to be able to succeed and complete different missions. But you can certainly build any base or any configuration of your robot that you choose to. There's even, I haven't built this one yet, there's an advanced driving base assembly, so it's a little more involved, a little more intricate, but it's certainly something you and your teams could do if you want to explore it. So let's start off with getting our robots moving and being able to code, learning the basics of Scratch. If you go down to My Projects, everything that you build and create will start here. That you have already created. To start a new program, do that from the home screen and click on New Projects. When you open up your project, it'll ask you to name it. You don't have to name it now, but you certainly can. What I would recommend to do is name it whatever mission that you are trying to complete. And we're going to work with word blocks. Icon blocks is a little simpler, not as inclusive, not as many features, but more similar to the old software. But the word blocks is what you're going to want to be coding with, and that's going to be the Scratch programming language. And you'll click Create. So this is our workspace. On the left side, we have all of our different types of coding blocks depending on what we're trying to do, and they're all color coded. Motors are in blue, and these are just to control a specific motor, not to get your robot to drive. Movement also controls motors, but it'll control 2 motors at a time, the ones that you'll be driving your robot with. We have lights, which will allow you to control and change the LED matrix that's built into the Prime. Sound, there's a small speaker on it. Events, control, sensors, different operators, and these are more advanced that we're not going to explore today. Variables are all here. Okay. One thing, I'm just going to take a step back. One thing I did forget to mention for our brand new users, when you go to your home screen, if you click on Start, these 6 very short little tutorials are perfect to understand how to use the light matrix, how to very quickly control a motor, and very quickly understand the sensors. We're going to go through the first 2 together to get our robot moving, but I want to let you know that these are here for you as resources. So we're back here. The first thing we want to do is get our robot. I'll be connecting through Bluetooth, but for our brand new Spike Prime users, you're going to want to connect. You're going to have to connect your Prime through a USB cable to update its firmware. I was not able to use my Spike Prime till I did that. It took about 10 minutes, and it did it automatically. I connected it through USB, and it did what it had to do. It said you need to update. Updated it, and 10 minutes later it was done. So when you click on connect, it's going to give you 2 options, Bluetooth or USB. It would be showcasing through my second device. If you want to make sure you guys can see both my screen that I'm sharing and the Spike Prime that I'm demonstrating with as well. So there's no screen on the front to turn it on. Large button down here. Just press it. We'll have a display on the matrix pop up, let you know it's booting up. Software froze. Okay, tap this Bluetooth button, and I got a little swirl happening. There we go. Then this little window will pop up on the right side. Once it detects it, just click connect. Then it tells you you're connected. Okay, we'll go back to project. So now robot's connected. Where it did say connect, it now shows the Spike Prime. And if you click on that, it'll give you a little dashboard to tell you that you have different motors or different sensors connected. We have 6 ports. They're labeled A, B, C, D, E, and F. And they're not specific to motors or sensors. Just simply plug them in, and later on, once we're programming, we will tell the program what motor or sensor is plugged into each port. And if we look at the dashboard, I have the right drive motor connected to port D. If I spin the wheel, you can see that yep, I can do that. Everyone can hear me, right? Okay. I don't know, my headset shut off for some reason. Okay. So that's how you connect to the EV3. I'm sorry, the Spike Prime. I'll do the same thing quickly with the EV3. And again, just this quick dashboard, you'll see the same thing with the EV3. It'll show the motors or sensors that you have, and as you rotate it or move a motor, you can see that the degrees of rotation is changing. If you hit this drop-down menu, you can change it. It can show power, percentages, or speed. But I like to keep it on position. Okay. And I did mention that the gyro sensor was built into the Spike Prime, and you can see that here. This detects the angle of rotation, so you can see that changing. Okay, here in this screen, this dashboard as well, it'll allow you to manage programs, to add or delete or change the order. The biggest difference between the EV3 and the Spike Prime is that there's no display. It's just an LED matrix. So we're going to go over this in a minute, but they're labeled as 0, 1, 2, 3 to how to select your programs to run them. And if you reorder them, they will change. So I want mission number is 0, training is 1. If I change the order, training is now 0, mission is 1. So when I select on the EV3, the 0, and run it, it'll run that training mission, that training program. And if I run number 1, it'll run the program for mission number, whatever one is there. Let me get this. So I'm going to go over the EV3 to connect it. I've had issues with a Bluetooth connection, but you can certainly do a hardwire if you've had issues. But I'll show you how to connect through that. Roy, does it need to be? What's your question? Does it need to be rested before it runs?
Hi, Eric. No, the EV3 gyro sensor, you had to be reset once you set the EV3 down on the table. If you reset it and walked over and tried to run it, it would get confused. I was wondering if the Spike gyro sensor is a little better.
It's better personally from my small experiences so far with the Spike Prime. I just got it a few weeks ago. And I think the biggest issue with the EV3 sensors is the type of connector. From my experiences, the EV3 used like the old telephone, similar to telephone connector. You had to plug them in. It relied on resting pin contacts, but there is some play with it, and I think that was always the biggest issue. But I have seen when you're looking at that data through the dashboard, I've seen that gyro sensor just continually run. So you have to unplug it and then plug it back in to reset. I haven't seen that issue yet with the Spike Prime. I think that was a sensor issue. I think now that it's from my experience, I haven't had that happen yet. Hope that answers your question.
Awesome. Yes, it does. And the other thing is with the loose connection, a pencil eraser cleans those things up nicely.
Really does. The biggest problem was for me was my students. As they're waiting to compete, I'd be watching them play and flick with that connector and pull the things out. So that was always unique. So I'm going to go over the same thing with the EV3 that we just did. Sorry if this is a little redundant. I don't know if I can connect two devices at the same time, so we'll find out. So I'm going to turn on my EV3. This one takes a little longer to boot up. But while we're looking at my screen, it looks nearly identical to the Spike Prime screen and setup and software. You have your home screen, recent projects, new projects, start, gives you the same basic system, starting your first program, motors and sensors, getting moving, driving, and building a base. In units, same thing, robot trainer, not as inclusive as the Spike Prime. Building instructions, again, are here. And then my projects are all the projects you have. So I'm in the same home screen on the EV3. The Connect icon is in the same spot. It's just a different symbol. So I'll click on that. So this gives you options, and I didn't mention that before. You can see connect via USB cable. That option is there as well for the Spike Prime. So turn on your EV3 brick. On the brick itself, you have to enable Bluetooth. So you go over to, let's see, I don't know how you can see that. Bluetooth. Make sure it's checked on. If you're using an iPad, the bottom option says iPhone, iPad, iPod. Make sure that's turned on as well. But visibility and Bluetooth need to be checked on. And then you'll press this connect button. This window will pop up. Select Bluetooth device. It is searching. Mine, I've renamed Elm 6 because I have a couple of robots. That is this robot. Click on it, press select. After you press select, if it's the first time you're connecting it to your device, you will get a pop-up on the EV3 that says enter a passcode. The code is 0000. If you don't do that, it won't connect. And that may be some of the issues some of us may have connecting Bluetooth to the EV3.
Eric, can I ask a quick question about that?
Go
Do
ahead.
you press the center button on the robot, and you also click connect on the program? I think I just pressed connect on the program, but I never got the pop-up on the robot. Is that because I didn't press the center button?
If it's the first time you're connecting it to a computer, you'll have to press the hit OK that it went through.
Okay, thank you.
You're welcome. And just like we had on the Prime, we have our icon here. It's green. We know we're connected. This is the name of your robot, and these are all the sensors we have. Sensors and motors. The big between the Prime and the EV3, there are 8 connection ports. The A, B, C, and D are designated for motors only. 4 are designated for sensors only. Spike prime is all letters A through E, and it does not matter which sensor or motor you connect to where. You'll specify that when you program it. And just like this screen here gives us live data, as I spin the motor D is changed. Okay. Okay, so I'm going to start a new project just to get us moving. At the top of our screen, you'll have any projects that you were recently using or have recently created. Some district devices may certainly put restrictions on what can or cannot connect. So definitely get friends with your IT people to get them to help you out. I've had to do that in the past, and they've helped me out, give me different restrictions for certain devices within. So to get our robot moving, we're going to click on movement, and we have an event to start. Okay, when we start our program, it has to start with this block. When program starts, what is going to happen after this step, one after the next. So all of these are different blocks to be able to tell our robot to do something. The first thing we need to do when I'm working with the EV3 is to set which motors are being used to drive it. So we have this block here. We're going to bring it in and just connect to when program starts. The icon here has a little drop-down menu. The one on the left is the left motor. The one on the right is the right motor. I have ports C and D connected to my left and right motor respectively. So my left motor, I have to change to C. My right motor, I have to change to D. There are a few different ways to get our robot to move, but the easiest way to start is this first block is a move block. Drag that into place, and it's going to say move forward, and it's a drop-down menu. We have two options, forward or backward. So this block will only get us to move in a straight line for a number of rotations, degrees, or seconds. I like to start with rotations, and I'm going to explain why in a minute. Or a little bit later, it's a little easier to calculate distance. So one rotation will get us approximately 7 inches, and I'll explain how you can figure that out later. But we also need to end the program. So we click on Control, and we need to end our program with a stop and exit program. If it doesn't have this piece of code at the end, especially with the EV3, your program will continue to flash, and you and your team will have to manually hit this back button to end the program before you can select your next program to run. So all this is going to do, and you can see by this little dial here, that when I run this program, this dial should go forward back into its original place. Down in the bottom right-hand corner, we have a play button. We'll just say download and run. That will download the program to the EV3 and automatically start it. Okay. So what happened was our left and right motors moved forward for one rotation, and that will get our I mentioned that was about 7 inches. I can prove it to you. Okay. I don't know if you can see that, but we are right on that 7-inch mark. Pretty darn close. It's actually 6.9. Any questions? Want me to go over, clarify anything? I don't know if I've gone too quick. I know this is a lot at once. Okay. And this is just to get your program that you've created to your robot. During actual competition, we're not allowed to have laptops on the field. Everything controlled from the robot itself. So you'll have to navigate users, navigate through the screen. The first play symbol, I had named this was actually named project. So the first one up is project. If I press that button, it'll run it right from the EV3 itself. Okay. And during each of the different programs that you have to complete your different missions, you'll simply scroll through them using a D-pad. This is up, down, this is up. Pick your next one, press the center button to start, and it'll run that program. Okay. The Spike Prime is a little different, doesn't have a screen or a D-pad, but it has an LED matrix on it. All the programs are simply identified as numbers 0, 1, 2, 3, 4. The left button here cycles left, right one cycles through right, and to run it, you just press the center button, and it'll run whatever you've programmed. Okay. Maybe a little more challenging for students. And I'm pretty sure this is still legal. I'll have to confirm with Troy. They used to be able to bring a cheat sheet of what each mission was or mission order. I would have your students have that cheat sheet with them at the table. For our Spike Prime users, mission program 0 is going to do this. Program 1 is going to do this. Program 2 is going to do this, to help them remind them, and then even put it in the order in which that you want to complete them on at the competition, what order you want to complete the mission in. Easy peasy so far. Cool. How do you rename? So right now I'm on project here. You simply go to the top and just press rename. When you rename, when you press save, change on your device until you hit that play button again to download it, or actually just the download button itself. Again, the play button will download it to the robot and run it. If you just press download, it's basically saving your changes to the robot without having to run it. I would highly recommend a laptop. The app is not all inclusive. There are features missing. It works in my classrooms with my students, and it works. The competition, it's a little involved. What I would do in my classes, when I have my robotics unit, you're going to want all the features possible to be able to do the best you can with the competition. Personally, so let me switch back to the Prime. Still connected. So I started a new program here. It just got us to move forward in a straight line. We're going to have to start our program the same way. As to which ports they're connected to. Mine are connected to C and D. And ways to start turning, right? Because we're not moving, or we have directions other than straight lines. Two different ways to do this. Right, left, basically steering wheel. The check method. And this will be a broad curve. So when I run this program, what rotation measure? Great question, and I'm going to give you this later. You can take a screenshot. You're measuring the circumference of the wheel. Are 2.2 inches, 56 millimeters. Pi times diameter gives us the circumference, and it calculates to 6.9 inches, round up to 7. So if you know the distance from home base where you're starting to the first place you want to get on the field is 14 inches, set it to 2 rotations. And you can calculate exactly how far you got to go and check along the way. Right motor is in D. Let's see. Why did that turn right? Left. Okay. The move command is what used to be called move steering in the old software. And it's just a broad, and this is really like a guess and check method of turning. Not my way to get your to get to where you want it on the field. In my personal opinion, and the best success my teams have had, move in as straight of lines as possible, not broad curves. But that's me and my experience. So move to a straight line, and I'll show you the next method of turning. I would what used to be called tank control. Okay, that's not it. There it is. No, that's not it either. Hold on. There we go. Okay, it's the last one on movement where we're only controlling one motor. Okay. Just had it. Sorry, team. Set speed. Okay. So movement is good for moving straight or broad turns. I like to personally pivot and turn on one single around one wheel, one pivot point. I also like to control the speed at which our motors are going to. The fastest speed possible isn't always the best. So if we add this block in, set speed to some percentage, it will change how fast and quickly that motor runs. So what this allows me to do, my left motor will run forward for one rotation, and it'll actually, so and my right motor won't move at all, and it'll get me to turn right. Okay, and almost a 90-degree turn. Again, depending on where you're trying to get on the field, you play with that number, the number of rotations, and you can use decimal points. You can use 0.9, 0.8, 0.95. Try to get you to turn as accurately as possible on the field to where you need to go. Both are great methods for having you turn, but I'm not having a broad turning angle or pivoting. Personally, but it's up to you and your team want to experiment with. So installed here just to save something and bring it back. And a program I had started already, a little more complex, but we're setting our motors to C and D. I have set my movement speed to 10%, so it's going to have us move pretty slow. We're going to have it move forward for 5 inches. And I found you can do rotations, you can do inches. It's surprisingly accurate, the Spike Prime. The EV3 doesn't offer this. It's only rotation degrees or seconds. So this may help you get to different places on the field a little bit differently. Then I have connected to port E, single motor, single large motor down here that's connected to this grabber. Run it as which can be good. It can be from.
Hey, Eric, excuse me, but your audio is cutting in and out. I'm not sure what's going on there.
And your code, what you're trying to keep building.
Eric, this is Ellen. I can't hear you at all.
Okay. Give me 1 second. How about now?
It's good.
Much better.
Okay. Always have a backup plan. Okay. And depending on where you're trying to get on the field and what you're trying to accomplish, your code is just going to keep building and building layer by layer. So if you have to get to a certain spot on the field, that's how you're going to want to get there. Motor E that I've set to is connected to this little arm grabber. It just flips down, and then I'll have my robot move backwards. and then it'll flip back up to release. Something I want to mention with the Spike Prime software before I run this, down here you'll see the little number 1 on the matrix. That'll is where it's going to store it. So you're not naming the missions that you have these programs that you have named don't correspond to will correspond to the number you have here. So when you select on the EV3 the number, when you run program 3 on your Spike Prime, it'll run this program. Questions? The EV3 with less options. The options should be the same. You have decimal points on the EV3. The same way you can program this is the same way. So if you want to go 4.5 inches, you can do the same thing with the EV3.
What was it that you were saying, Eric, that where it was different on the drop-down menu? Was it the there were two options you said the EV3 didn't have? Is that just the functionality difference?
I believe so. It just for what did I say was different? I'm just trying to remember. What was
It was in one of the drop downs. I had 6 options, and I think you mentioned 2 of the options didn't exist for the EV3, probably just because it doesn't
Okay.
have that.
Okay. All right. All it is the amount of inputs that connect to the hub itself.
Oh, okay.
So the Spike Prime has 6 inputs: A, B, C, D, E, and F. And the EV3
Eric.
has 8.
Eric, I think she's referring to the sub options on the movement where you had inches and degrees and
Yes, that was it.
centimeters.
Yep.
Okay. Okay, so here's my EV3 screen. When we're moving forward, right, it's only rotations, degrees, or seconds. Okay. So if you're using an EV3 and you want to go forward 7 inches, when we calculated the circumference of our wheels, 1 rotation will get us to go 7 inches. For those with a Spike Prime, our movement is the same ratios, rotations, degrees, and seconds, but also this Prime has the ability to measure centimeters and inches built into those motors, so it can better calculate how far it's going. So it kind of eliminates that need to calculate your distance for your team. Does that answer the question?
Yes, so we just have to do math? All right.
Just a little bit of math, sorry.
All right.
And this is the very, very basics to get us going. Any questions? Anything you want me to go over again? Anything you want to explore further?
Will you be running a command to pick up?
It's whatever device you have. So the thing that I have set up here is this little motor connected to this little arm. If your team builds a grabber, it's the same concept, just whatever motor it's connected to, you would have it run for an X amount of rotations to open or an X amount of rotations to close. But it's whatever motor is controlling that grabber is what you would set. Does that answer your question?
Yes.
Okay. One thing that I would want to share, if you go back to our home screen and we go to help, there are a lot of coding blocks. If you go to help and you go to word blocks, it gives you a much better explanation of, and in good detail, of what every one of those coding blocks does. Another good resource to have. Every one of those blocks is here. Okay, so you have this to calculate robot movement. A lot of the stuff that my team struggled with early on was how do we actually do the things that we need to do within these missions, right? It's a little more than just putting something on a field. It's grabbing, picking things up, or moving them. One great resource that I found was this book here, Lego Technic Simple Machines Idea Book. A lot of simple machines out there to be able to move and pick things up and grab and turn motion into another direction. This was a great resource that my team has used in the past to be able to use to help figure out how to make something work or how to make something move. There's a ton of websites on First website. First does have a YouTube channel. There are dozens of teams out there that put out videos on YouTube as well to help teams, to help mentor teams. Bricklink.com is a great resource to purchase secondhand Lego parts for pretty big discounts. And specific pieces you'll look for. Every Lego piece has a number printed on it. So if you're looking for more of a specific item or a specific piece, you can search just for that number and it'll come up. And it's just like an eBay for Lego parts. Things to consider when you're building a robot. How complex do you want it to be? What are your time constraints? How often are you meeting? Remember, you have to do things in 2 minutes, 2 minutes, 2.5 minutes. Completely forgot. Making sure you're able to do everything that you need.
2.5.
2.5. Completely. It's been so long. Completely forgot. You and your teams decide what missions you want to attempt. Try to figure out what point values are the ones you want, are the easiest for rookie teams, for new teams. Figure out what's realistic. What can you accomplish, and do that one and do it well, and then see what else you can add on to it. Take your time with your navigation and alignments. You can use a stencil or a fixture, if you will. A jig, to get your robot lined up perfectly from the home zone to get you to where you need on the field to make sure it's a consistent starting position every single time. Make sure your batteries are always charged. Try to make your battery accessible if you want to replace the battery. The EV, I'm not too sure about the Spike Prime. I haven't used it enough to really comment on it. But I know the EV3, the motors are voltage dependent. And what I mean by that is When your battery is fully charged at 100%, the motors will run at a certain speed. When the battery is running low at 50, 25%, the motors will actually run a little bit slower than they would at 100%. So you may have performance issues. Your robot may not do what it was originally programmed to because of the different changes in battery level. That also goes with not even just the competition, but when you're writing your code. If you've been working for 2 hours and you're programming something and getting something to work from the beginning of your session to the end of your session, your programs may work differently because that battery voltage has changed. And another great way, flowcharts. It's a diagram that represents your workflow or the process, what you're trying to do. It's a step-by-step guide that you create to help solve your task, your mission. Okay, think about where your robot wants to start. Obviously, it's in home base. Where do you want it to end? And how are you going to do all those things in the middle? And write that out step by step. All right, to get to a certain place on the field, we need to move forward. Then we need to turn left. We need to move forward again, turn right, close a clamp, and then do it all in reverse to get back. Okay, that's going to help your teams decide, your team members decide and help plan better how to write their programs, getting those things step by step, how to get them to think about the process that they have to take to get to one place and all the actions that need to get there. And finally, some final tips. Check your ports. Not a big problem with the Spike Prime, but has been a problem with the EV3s in the past. Those connectors. Roy had mentioned you can clean them with an eraser, but sometimes just those little cables, they may not be pushed in all the way. Your students may have played with the clips to release them. So if something is suddenly wrong or something not working how it should, check those connections first. Don't be afraid to try new things and experiment. There's plenty of failures before any successes. There's 1,000 ways to solve each one of these missions. If something's not working, take a step back, see if you can approach it a different way. Check your coach's manual and game updates regularly. Your coach's manual has a lot of great resources to help you set your teams up for success. And to end, if we want, but I'll be here if you want more. Make sure you know the core values and respect the gracious professionalism that FIRST is all about. Make sure you take lots of notes and pictures to understand everything that's going on. Document the process. It's a good way to look back from year to year. Read the coach's manual. Consider volunteering, and of course, have fun. That's why we're all here. Have fun.
Hey, Eric, thank you very much for all this. And I'm not here to throw anybody out, but it is a little bit of a time check that I don't want anybody to feel compelled to stick around because we're right at about at the limit of where we expected to be. But thank you very much. I want to also point out that while you all have been doing this, I've been busy putting some links up on the website. So there are a couple of, I'll get some more from Eric. It looks like there were some suggestions in this session. I know that Chris suggested a site called Builder Dude 35 and EV3 lessons. And so those links are up there, but we'll add any links that Eric wants to add as well. A lot of the things that Troy provided are linked up there as well. We're going to try to get all of the videos ready to go, but of course, can't get that started until we finish them. So hopefully in the next few days, we'll get some more videos up there. I did see also somebody mentioned here Carnegie Mellon, and I know they have for years had quite a program and just generally getting started. I don't know if it's going to cover Spike Prime by any means or anything like that specifically, but in a more general sense, they might even have some continuing education stuff there. So just wanted to pass that on.
Okay, thanks for that, Rick. And I'm here for a little bit. If anyone has any other questions, if you want me to go over anything, especially with the programming, that's usually the most confusing. I hope this was useful. I hope you learned something, and a couple of thank yous. You're all very welcome. And I'm here if you have any other questions before we head out.
Eric, can I ask a quick question just on programming, like a really basic? Are we putting into the EV3 and naming on the Scratch program the actual missions as well as basic commands in case they need to troubleshoot? So will the program on the EV3 have a mission number, but then will there also be, like a move forward, turn left, separate command so that they have to really toggle through?
When you're controlling it from the EV3, you're asking?
Yes, like at the actual competition, like is the end goal to have the missions? I get you've got to put the missions on and we'll name the Scratch program the name of the mission. But should there also be a menu item of other basic commands so that at competition, like if they need to do, like move forward and pick something up to do damage control, they should be able to do that from the robot, right?
Yes. So anything, you can certainly have that. And I've seen teams have that as well to try to maybe just sweep something out of the way that might be in their way that caused accidentally. Everything that you name your projects is how it's going to appear on the EV3. So if you have a program called Grabber, and that's going to pick something up, right? Grabber, you're going to select the Grabber. You're going to select the Grabber program through the EV3 and then press the start button and it'll run that program. You can name them however you want, whatever you and your team are going to remember. But of course, you can have that cheat sheet. You can name it Mission 1, Mission 2, Mission 3, Mission 4. You can name it literally anything you want as long as your team knows in what order or what it's going to do. In case, the order doesn't really matter. You may try one to complete one mission and it doesn't work and you want to skip it because you want to keep going through everything else in your run and you find out you have time left at the end of the match and you want to retry that one mission that you ran, you can just go back to that one and run it. But if you want to have damage control, you certainly can as well. But that gets a little more challenge to predict and pre-program because you don't know where that obstacle may lie, if that makes sense.
Okay, great.